So the track season is underway next Tuesday and Thursday. Yes, I understand some of you are going to be gone. All right. So with this, okay, we've got this double replacement reaction. So that means something is getting replaced twice. Okay? So what is the best way to describe this? Okay? These compounds get split apart. The charges will not change from one side to the other. Okay? Go by your negative ions. What's the charge of the nitrate ion?
-1.
What's the charge of this copper?
+1. +2. It can be a +1.
Okay? -1 times 2 gives you -2. 2 times 1 gives you +2. What's the charge of the bromide ion?
-1.
What's the charge of potassium?
+1.
Those add up to 0. Okay? So now, do positive ions bond to one another? No, they do not. So, you split these up between the ions. Okay? So with that, split it apart here. So you pick potassium or copper. Okay? So copper being a +2 charge is going to bond with what from this, but on that side. Okay?
You need 2, bro.
Okay? Now, what does potassium bond to? A little more specific. Okay? Of these subscripts, do any of them go over there for sure? Why did this 2 pop up? Why did that 2 pop up? To balance out the compound. Okay? And then
The 3 is part of the formula.
for the nitrate, that has to come over here because that is part of the nitrate formula. Okay? So, do we want to work on balancing this, or are we good?
Yeah, work on it. I might as well.
Okay? All right. We're asking for input. We're receiving our input. Okay. Copper. What else do we see?
Nitrate. Potassium. Bromide.
Okay. Copper's left.
1,
1. Nitrate's left and right.
2, 1.
Potassium's left and right.
1, 1.
Bromide's left and right.
1, 2.
Okay. So, do you want to start with your bromides or your nitrates?
Nitrate. 1, 2, 1, 2.
You say the nitrates? Okay. That 2 gets distributed through the entire compound. What does that do to your potassiums?
2.
What does it do to your nitrates?
You got 6. 2.
Okay. So how do we balance out our potassiums now? Okay. There you go. 1, 2, 1, 2. Okay. So I see a lot of you are writing this down. That's doing the right thing. Did I say ting? Doing the right thing is what I meant to say. Okay. Now, this, you were told it was a double replacement reaction. Okay? With this one written in blue, what type of reaction does that look like? No and no. Why is it synthesis?
Because it's put in by
Because you're taking 2 substances and putting them together. Okay? And if I'm willing to bet that's what it said in the materials we talked about in class. Otherwise, in chapter 19, it's a little more wordy, a little more words put into it. You could certainly look in chapter 19, it will explain the same thing. because on the left it's a neutral molecule, on the right it has been ionized. For those of you who go on and you a lot of jobs, yes, you're going to work for your hands. If you decide to become a welder, okay, magnesium is really tough to deal with. I mean, not just magnesium itself, but if it's a type of alloy that has magnesium in it, it just spontaneously reacts with the oxygen in the air or the water vapor, and you get bursts of heat and flames and fires. It's just tough to deal with. So you're creating that magnesium oxide just because of the chemical properties of magnesium on its own. Okay, symbol for magnesium is what?
Mg. And that's a +2 charge.
Plus O.
Okay. What is magnesium oxide?
MgO.
Is this correct?
Yes.
Oh, let me check.
So if you proceed with this way, it's going to be wrong. You're right, but why are you right?
It's diatomic.
It's diatomic. Okay? Gases and halogens, when they're on their own, are diatomic. So you need a little 2 there. Okay?
So put a 2 in front of your MgO.
But are we done on this side, though?
No.
Okay? What's the charge of the oxide ion?
-2.
What's the charge of magnesium? So that adds up to 0. So we're good with that. So we've got 2 oxygens here and only 1 over there.
You're going to have to put a 2 in front of the magnesium and
Then put a 2 out from there.
so
Okay?
2, 1.
2, 1, 2. There you go. Now, you can ask any junior, any senior. For those of you who are going to proceed forward, you young men and women going on to take general chemistry and this in college, okay, if this is something that you struggle with, you just can't do general chemistry. You just can't. We hate to say that, but it's just really, really going to be difficult for you. It doesn't mean that you can't get better at it. It just means it's going to make it difficult. Okay? Just like it doesn't mean that SDSU can't win today. They possibly can, but the reason that it's going to be tough for them is their opponent is a lot taller than they are. Their average height is somewhere around 6'10". Providence. And when you look at their point guard, is it Shireman? Is that his name? He's probably their best shooter, so he's probably going to be covered up. But Providence depends how much scouting they've done.
They got old Douglas Wilson.
Okay? So it doesn't mean that SDSU can't win. It just might be a little more difficult for them. Okay. What happens in a combustion reaction? Okay? I'm going to put it over here. Now, in this combustion reaction, is that going to be difficult to balance? Excuse me. It's not that some reactions are more difficult than others, but why is this easier to balance than that?
It's odd.
Because this is an odd number, okay? So it makes it just a little more easier, okay? Do you want this written out like this?
We'll be all right for this one.
Well, I'm asking for input. I hear we're all right. Anybody? If you say write it out, that's what we're going to do.
Chris wants it written down.
Okay.
Awesome. Easy.
Okay. Carbons left.
3.
Carbons right.
2. 1.
Oxygens left.
2.
Oxygens right.
3.
Hydrogens left.
8.
Hydrogens right. Okay, so since this hydrocarbon, hydrogen carbon, since that is odd, what can we put in front of here? Okay, we don't have to double this right away because it's not an even number.
All right, you got 7.
Okay, so let's fix our carbons.
Put a 3. 3 in front of your own side. What size is
Okay, how many oxygens is that?
6.
How many oxygens is that? 3 times 2 is 6, and you've got that one remaining over there. Okay, now, the next place to start is with your hydrogens, because we don't want to be messing with this oxygen and saying, well, if we've got 7, let's just take it times 3.5. It doesn't work that way. Okay, so if we've got 8 hydrogens over here, how do we get 8 over there? Put a 4. 4 times 2. Now do your oxygens. 3 times 2. 4 times 1. So 6 and 4 gives you 5 times 2 gives you 10. So 1, 5, 3, 4. And this might be a little tough to see, but it's iron 2 oxide. Okay? For those of you a week from tomorrow, do we have any, can you donate blood? Or you got to wait 1 more year?
How old do you have?
16.
Okay. All right. So if you donate blood next year, or whenever it is that you do, this is the major component of hemoglobin. Okay? It's the iron ion that bonds to oxygen to carry that throughout your body. This is in blood. Okay? So what that means is we need to write this out. What is the formula for iron 2 oxide? Iron is, okay? What's oxide? So what happens when things decompose? They split apart. But are we done writing this here? Yes, we are. Because what's the charge of oxide? What's the charge of iron? Or +3, but we're telling you what the charge is here. Okay, +2, that adds up to 0. So when this splits apart over there, why are we putting this 2 there? Well, we did here and we did there because it's diatomic. Nothing's changed. You got 2 oxygens over there and only 1 here. Put a 2 here, then you got it balanced. Now, again, those of you doing cooperative learning, that's great, but you are responsible for that on your own. You got to keep that in mind. All right. Is there anything you feel you want to go over? If it's a halogen or a gas, but not noble gases. Okay. Anything else? Okay. So we're going to stop there. We'll catch up to you next time. We got a paper that's going to be assigned here in just a moment, and it says it's due on the 22nd, which would be next Tuesday. We'll catch up to you next time.